welcome back. We will now continue, so I hope we have everyone back on board. And I will now introduce you, the speakers, for our next block, which is the Advanced Planning and Control. And we will start with Fabrizio Costa. So welcome. He is a program manager at AWS Data Center Engineering and also co-founder of the AI and PM research group, and is as well a PMI Global Construction Ambassador. And Fabrizio will speak about the framework gap in data center delivery, so managing speed, risk, and complexity in the AI infrastructure era. And I'm really looking forward to listen to you now. And Fabrizio, we can see your background, but we cannot yet see you, at least me. So
Okay.
maybe you have to open the camera.
Yeah, so can you hear me?
We can hear you, but
Okay.
I cannot see your. But I
How
think we also have a minute if you want to dial back in
how
again.
about okay. Can you hear me?
We can hear you, yes.
And can you also see me?
No.
Oh, is the
Uh,
camera not working?
oh, no. Oh, sorry. Now I have you twice. Now we see you. Oh, sorry.
Oh,
I
all
was
right.
searching between all the boxes. Yeah,
No
now you are
problem.
fully here. Wonderful. So handing
Okay,
over to
my
you.
apologies. All right, so let me share my screen real quick, and my apologies for those issues. Okay.
Yes,
Okay.
presentation is also visible. Wonderful.
Okay, let me just organize my screen here. All right. Can I start?
Yes, the stage is yours. Thanks.
Okay. So first of all, thank you so much uh, for the global construction team and the organizers for having me. It's a pleasure. It's always a pleasure to serve PMI and talk about um, okay, talk about data center design, construction, and delivery. So for today, just a real quick, I'm Fabrizio Costa, and I'm a PMI Construction Global Ambassador. And in my day job, I'm a program manager in data center design and engineering at AWS or Amazon Web Services. And um, oh, sorry, 15 15 years plus experience in construction project management, link construction project controls across Brazil and United States. And for today, I would say that I'm wearing two hats: one as a practitioner, and two practitioner in data center delivery, and two as a construction global ambassador. And just a quick disclaimer, so everything that I'm going to talk here and to present here represents my own views for the data center process. So this is not reflecting what the companies that I work on or that I worked before represents. Okay, four things that I want all of you to walk out able to do. The first one is recognize that the framework gap and decision depth in your own projects, not only on data center projects. And second, see how a compressed decision doesn't disappear; it transfers forward, which is a big issue. Map the four forces in this sector to a planning and control response, not an execution one, and apply three instruments that actually close the gap. Okay, the boom. Uh, Speed is demanded before the design is mature. So let's set the stage and just to do some reflections on why this and why now. So when we think about data centers, we are thinking on the physical infrastructure that supports one of the world's largest innovation wave in terms of capex investments that built environment has ever seen. Capacity could more than triple by 2030. So we are always achieving breaking new records with capacity, but it's what is most surprisingly we are tripling this capacity that we are seeing right now by 2030. And only mechanical and electrical systems, just to give you an example, inside those buildings alone represents about $250 billion. So here's what what makes our job really hard is what we call the power density that goes in the rack, where we have the servers and the switches and all the equipment that runs inside of the data center. So that power density has gone up 10 times in just a few years. Just to give you an idea, every time when we see new releases from NVIDIA, we can expect people on the infrastructure side is discussing about power density. Um, so even the most experienced operators who have done, let's say, 50 times data centers, they are hitting what we call first of a kind conditions every generation of the data center. So the pressure of all that create is let simple. Speed gets demanded before the design is mature. So I think it's very important to hold on that line, and because this is the root of everything that we are going to talk about next. Um, so we are in the a construction event. This is not a data center event, and I thought that would be interesting to bring what is the anatomy of a data center. Um, so data centers are a mission critical facility filled with computers, servers, switches, and very uh, demanding electrical and mechanical equipment that keeps every one of them running. So just in terms of a reflection, every AI model that we've been using, every agent, every inference workload, oh sorry, there's some back noise. Um, every inference workload and every piece of digital infrastructure that's reshaping how the world works. It all runs on a data center somewhere across the globe. So basically, in any data centers, we have three systems. On the left, top left, we can see the power chain. We have transformers, generators, switchgear, UPSs, ATSs, so many different equipments. And one important thing on the power side is the long lead times. And for example, for a switch gear, we are expecting currently 50-week lead times, at least 50-week. On the right, we have the cooling portion of the data center. Chillers, towers, AHUs, cracks, and all these units is intended to do one simple thing: reject the heat. And in the middle, we have the white space, and where the racks are, the actual computing is happening. So everything else in the building exists to feed those racks and to keep them alive. So it's something that we say at Amazon for the design engineering team, our customer is the rack. Um, okay, so just one idea that I wanted to start. So just moving forward with the concept that I'm bringing, one idea that I want to name for you. So between compressed schedules immature design, long lead equipment, permitting processes, technology velocity, and operational readiness the business actually wants, there's a space. And that space, I call it as a framework gap. And everything that we're going to talk here lives in that gap. And being specific about the decision depth, here's what happens. So a planning decision gets oh just a connection why I'm mentioning about the decision gap. It's because the gap that I just mentioned before, the framework gap between maturity stage and planning phase, is born here is it's where the decision depth is. So a planning decision gets so what happens? A planning decision gets deferred, or it's left unclear, or this is a real killer in my opinion. No one owns it. Work doesn't stop; it keeps going around the gap based on assumptions, and I think it's pretty common for all of us here. And we declare a phase complete when the scope was never mature enough to support it. So we just keep going, but the scope is not there yet. And based on that, here's what we see later: rework, loss of productivity, schedule variance, and it's all common words that we see in the construction world, and usually we labeled it as an execution failure. And in my opinion, it's not an execution failure. The signal was there much earlier. The signal was at the planning stage. We just didn't have a structured way to see it. And here's here's the most important thing for about the decision depth. It doesn't stay where it's born, it transfers forward every time. So that's the where the big problem starts. Um, Design is where depth originates. The decisions here set every downstream outcome. Construction is where it transfers. Every upstream decision arrives at the same time. Commission, it's where it surfaces, and that's a hard wall because the date was set by a commercial commitment, not by whether you are actually ready. And the operation inherits everything. So everything that moves across the life cycle goes through operations, including the retrofit roadmap that nobody wanted to write because of the way that the technology is moving. So if you compress one phase and you did not save time, you push the problem forward, and every compression pushes it forward. So it never removes it. So what's generating this debt that it's moving across the life cycle? In my perspective, I see as four, and specifically for data centers, I see those as four forces. Uh, I'm deliberate about the word forces, not failures, and I'm going to explain uh, about it because to me the minute we call them failures, the next move or the rational move is to find someone to blame. And to me, it's useless. These are conditions of the sector. I understand it. They apply whether it's your 50th data center or your first. So, talking about the forces, the first one, design speed without design maturity. um, we have it's very characteristic in the data center industry. We have fast followers copying the pace of the hyperscales, for example, without the foundation to do it. We have the force number two, which is post design bottlenecks, permitting and construction, the two things that you generally cannot compress. And the third one, supply chain as a design constraint. This is very, very important for data center. And the force number four, technology velocity, the risk that we are delivering something that it's already obsolete. So every one of these has a planning and a control response, not an execution one. And let me show you that with the force, which what the force that bites hardest. Okay, as I mentioned, in data centers, supply chain is a design constraint. Um, long lead equipment such as generators, transformers, switch gears, those all carry at least 50 week lead times. So the commitment gets, if the commitment gets early before the scope is fully defined, and one thing that I wanted to be honest about this is not a mistake. This is how the data center world works, and the market gives
Confermo.
you no choice. Waiting
Confirma
is
el
not an
estado del
option,
calentador,
and it's not the answer. Oh, there's
Víctor.
some back
If
noise.
you are not speaking, then please mute yourself. This would be wonderful.
Ya,
Thanks.
está regulando.
Valentin, can you please mute yourself? Thanks.
Okay. Okay, moving on. Here's the trap. We commit that equipment against an immature or project specific scope, and one change later cascades redesign, resequencing, and cost. The decision was made early, but the debt that I was talking about before, shows up downstream. So, what to do what do most mature operators in data center do? They don't wait for perfect scope. There's no time for it. They mature what we called a standardized reference design, and they commit long lead equipment against that. Scope maturity in this specific case, scope maturity moves upstream out of the single project. But, and this is the part I really want you to think about it, is that a reference design is not something that you set and forget. Um, technology velocity makes last year's baseline totally wrong. So what construction, commissioning, and operation learn has to feed back into the template that we developed and maintained that way. The reference design is where the broken loop finally closes. So I think it's a very important item, the broken loop that I'm going to mention further. We are going to come back to it. And just here, this is not only my opinion. Construction Industry Institute research on scope definition showed that projects that authorize with a strong scope score, so we can see here the thresholds are greater than 200, less than 200, come in 5% under budget. So the ones that don't, 25% over, 13% behind schedule versus 30%. It's measurable, so I call it as earned speed, not borrowed time. Okay, I mentioned about the broken loop, right? And everything we talked about, in my opinion, plays out here. And to me, in most cases, this loop is broken. So the forward arrows, when we are moving from design to construction to commissioning to operations, they always work. The project flows forward whether we want it or not, and the debt flows with it. But the ones that are dashed, the feedback arrows, the ones that would carry what operations or what commissioning or what construction learned across the path back into the next design, these ones rarely exist. And that's, in my opinion, this is not because no one cares about lessons learned. It's because no one really owns that transfer. Closing it takes shared vocabulary and persistent documentation, a community of practitioners that can be internal or external, and increasingly a synthesis layer that can finally carry it. And I think it's where AI nowadays comes in. Okay, so in terms of reality check, because I don't want to give you some information that it's only Fabrizio's theory. So PMI's Pulse of the Profession this year found that roughly 1 in 3 complex projects failed to deliver the benefits they intended. I think that's very strong. 1 in 3. And the practices most associated with success are the ones that applied at front end before execution. We're talking about the planning phase. Um, the title of that report says it better than I can. We're moving from navigating tasks to navigating systems. So, if the front end is where success is decided, I think we need to talk about the answer. And I wanted to be clear what the answer is and why it isn't. So the answer to a structural problem is not a better, let's say, firefighter. It's a structure and built in and built on purpose. So um, three instruments, and the I believe you would agree with me. Those are not exotic. They are built into how we plan and control the work. First one, scope maturity assessment. So make the phase gate a readiness decision, not a calendar date. Uh, the tool here is the PDRI. Quantify how, I think the most important is quantify how mature the scope really is before it sets to the next phase's clock. The second one, interface management. Register every equipment and the trade dependent handoff. So so cascade risk is tracked, not discovered at the worst possible moment. And the last one, change control and commissioning readiness reviews. So checkpoints that catch the mid-build shifts before they compound. So I believe you would agree that none of this is new. It's tested. It's in the PMI construction professional body of knowledge. So um, okay, so I mentioned about the data center, the infrastructure, and I just wanted to mention AI because to me, every conversation in our industry right now ends up with some AI discussion. And I just wanted to reframe it that the constraint was, in my opinion, was never information. So in construction, we always have dashboards, reports, data, softwares. To me, the constraint is the link between the information and uh, the decision it's supposed to support. And my line on AI is that AI amplifies a decision system that already exists. It doesn't create a new one. So, for example, hand a perfect signal to a team with no structured way to act on it and nothing changes. So, this is not a problem for AI. It's a problem of the way the system is set and how the information is linked. So, where to me, where AI generally earns its place, um, it's on three things: pattern recognition across the project, so no single team has the history to see. Decision timing, surfacing the signal while the window is still open, and closing the feedback loop, the one that I mentioned before, keeping the reference design that I also mentioned before current from a portfolio data, so the synthesis layer that finally carries the feedback arrow we talked about. But here's the a hard I would call it boundary. A signal with no owner produces no action. So however good the signal, AI surfaces. The organization still has to decide, and to me that's exactly how PMI's new and recent AI standards frames it. Human oversight and accountability as first class principles, not an afterthought. Okay, moving on to the end on my side here. Four things to carry out of this room. One, decision making is the bottleneck, not execution. The constraint is upstream. Two, debt transfers forward always. Every compressed decision becomes someone else's problem downstream. Scope maturity is the first intervention. It decides how much debt enters before the clock even starts. And lastly, AI makes the decision system visible to itself, but only if the system exists. I think the focus is build it first. And just a final thought that I'm going to leave you all with this. The more complex the project, the more intentional the management system uh, needs to be. And just a reminder, debt transfers forward every time. The only question that matters is whether the team receiving it knows it's coming and has the tool to contain it. So that's the work. Thank you so much. There's some references and sources that I used. And that's all from me.
Thank you so much, Fabrizio, for this well insightful presentation. And looking at the clock, we might have time for questions. So just looking around in the chat, I could not see anything, but maybe someone wants to raise their hand. Okay, but maybe let me otherwise ask one. So you introduced these three instruments. What is, from your experience, the hardest one to implement? So
I believe closing the feedback loop. Uh, oh, sorry. Scope
I
maturity.
meant
Sorry.
this. Yes, exactly.
Yeah, the scope maturity assessment. I think it's the process itself. I would say that it's not hard, but the environment make it hard because, especially in data center industry, we are always trying to move as fast as we can, and um, it looks like that okay, we have this reference design, let's make some adjustments to reflect the latest technologies movements that we had, and let's move forward. And
Mhm.
sometimes we need to better understand the impact of those technologies changes, and so take a look on take a reassess the scope and making sure that we are understanding all the impacts across the different disciplines and across the final product so we can move on and not carry the debt, not transfer the debt for the next team that is going to manage the project.
Absolutely. Thank you again for also this answer, the presentation. If anyone wants to connect with Fabrizio, I also share the LinkedIn profile in the chat, so you can directly go there and maybe also follow up with discussions. And so thanks again. And now, already
Thank
speeding
you so
up,
much.